In the last video, we talked about what Thevenin and Norton transforms are and how to find them experimentally and why they're important. In this video, I'll explain how to find them theoretically, meaning not in a laboratory, but given a schematic of a linear circuit with two output terminals, how to find its Norton or Thevenin equivalent. And it's important to realize that once you find one, you can find the other because they're just source transforms of each other. So that means that out of the three components of VOC, ZEQ, the equivalent impedance, and I short circuit, you only need to find any two out of those three, and you can find the third one out of Ohm's law. So let's begin. The first method, A, is the exact same as the experimental method. You'll begin by determining VOC and ISC. So in the upper diagram, if this is your circuit, you'll use the methods you already know how to analyze the circuit: nodal, mesh, superposition, that type of thing, source transforms, to find the open circuit voltage at the output terminals. And then you'll reanalyze the circuit shorting the output terminals. And this time you'll measure the current that flows, the ISC, the I short circuit that flows. Once you find VOC and ISC, you find the impedance by Ohm's law, and now you've got all three components for both the Norton and the Thevenin transforms. Let me group these methods to make it clear what we're talking about. The next method, I'll call it method B, is faster. The problem with method A is that finding VOC and ISC each requires drawing a completely new circuit. ISC requires you to short the outputs, and using new techniques, mesh or nodal or something like that, to find VOC and ISC. That takes a long time. Method B has you find either VOC or ISC, whichever's faster, it doesn't matter which. And then you'll find the ZEQ by zeroing the sources and using resistor simplification between those two output terminals. That's fast to do. Resistors are either in series or parallel, so you're either adding or using the parallel equation. And then, rather than analyzing the circuit to find the remaining VOC or ISC, you just use Ohm's law now that you've found two of the three variables. So the last method you're going to use if your circuit that you want to analyze is composed entirely of impedances and dependent sources. There are no independent sources in the entire circuit. And if that's the case, the entire circuit filled with impedances and dependent sources will look like a single impedance, ZEQ. There will be no VOC or ISC source there. The problem is, how do you get those dependent sources working? So to do that, you'll begin by applying a test voltage source, a 1 volt test voltage source or a 1 amp test current source to the outputs. And if you apply a voltage, you'll measure the current that flows. If you apply the current, you'll measure the voltage across that source. And then you use Ohm's law to find ZEQ. It's just the ratio of the voltage over the current.